Hello and welcome. My name is Christine Perey. I'm hosting today's webinar. This is a area research committee webinar on the subject of volumetric video. I'm the co-chair of the area research committee. This webinar is part of a series, focuses on emerging topics that augmented reality experts would want to keep their eye on, be aware of, and potentially experiment with. We are a committee that meets monthly. We manage our own bespoke research projects, develop tools and tutorials, and this series of webinars as well. We are very pleased to have with us today an expert on the subject of volumetric video, Lauri Ilola. Thank you, Lauri, for preparing this excellent presentation. During the presentation, people will be able to use the chat feature, the questions feature in their BrightTalk interface. And I'll be able to see those questions, and then we will answer those questions for people at the end of the presentation. So at the conclusion, there'll be a discussion. Don't hesitate to please tell us what's on your mind. I think that I also want to flag that this is part of a series, as I just said, and we will have announcements, and stay tuned, follow the AR for Enterprise Alliance social media and information channels for updates and announcements. So without further delay, Lauri, it's very, very great pleasure to have you here. So thank you for joining us.
Thank you, Christine. And I have to say, it's exactly likewise. So glad to be here. It's always good to be able to bring volumetric video more out there. So a brief introduction for myself. I just did the math. I've been in Nokia Technologies for 15 years now, and not to bore you completely, I'm going to just try to summarize the most relevant bits and pieces here. I started with 3D graphics. Later on, I moved into video coding and found that there's actually a very interesting overlap between the two areas of 3D graphics and video coding, which is no surprise, volumetric video. And since 2020-ish, 2017 actually to be exact, I've been looking into volumetric video, some early enablers, research, standardization, and now I'm running my own little unit focused on this topic. So that's my Nokia background, but I'm here more or less from the capacity of Metaverse Standards Forum and Volumetric Media Interoperability Working Group, which is a working group that I'm sharing together with my colleagues, Skip and Ralph. So that's basically the short bio. Let me get started with the rest of the presentation by giving a little bit of an outline on what we're going to be touching today. First, very quickly out of the way, let's talk about MSF and what the Volumetric Media Interoperability Working Group does. Then jumping directly in the definition of what is volumetric media, just to give people an understanding what we're talking about here. And then maybe the sort of the beef already very early up in the agenda. So what sort of scenarios and use cases there are for volumetric video. Then I'm going to dive in more into the details of how do we capture and record it, what sort of representation formats are out there in the industry that people are using, what sort of considerations there are for streaming and compression of volumetric data, and then also talking to you a little bit of the other side of things, how you see things, which is how do you actually display volumetric video to an average user. As a sort of special treat, I can share a little industry update, like a state of the industry description. This is a kind of a survey that we did as part of the Volumetric Media Interoperability Group in Metaverse Standards Forum. that scouted a little bit of the landscape of what the momentum of volumetric video is going forward and what sort of actions we as an industry should take up to kind of speed up the adoption. And yeah, finally, just a couple of key takeaways if you want to just quickly understand what sort of things you might want to walk away from this webinar. So, about Metaverse Standards Forum. It is a massive organization. It has around 2,600 member organizations, and it's a neutral venue that actually assists standards organizations instead of just being yet another standards organization. So MSF does not produce standards as such. It's focused on this kind of a pre-standardization phase, or meta-standardization, as you call it. It has a very broad global participation, and it's focused on very pragmatic and bottom-up industry projects. When it comes to Volumetric Media Working Group, we are a fairly new working group established last year. And we are mainly here to study the interoperability of various volumetric media-related standards and implementations. And again, we're not producing standards. We're just trying to understand what sort of technologies and standards are out there and what sort of functional interoperability could, in theory, exist between those. We have about 100 individuals within our group from very diverse backgrounds, from SDOs, technology providers, platforms, device and hardware manufacturers, and etc. We recently arranged a public town hall, which kind of also discussed a little bit of the survey that I just quickly mentioned. And this town hall is available on YouTube in case you want to see it. And this QR code on the page actually guides you to our website in case you're interested in knowing more on what we do and if you want to get engaged with us. So then let's start with the kind of definition of what is volumetric media. And there are many definitions out there. I chose this definition for the sole reason that this is what we defined as part of our working group charter. So volumetric media, it's a technology which enables capture of an object or scene in 3 dimensions, and it's playback independent from the original capture position and orientation. And it's important to understand here that we're talking about captured content and not as much synthetic or modeled content that a 3D artist might produce. The second part of the definition that is important is that it is actually representing 3D content. And what you need to be able to do with that is to synthesize new views from the captured content so that you can interact with the content and experience it from various different viewpoints and view positions. Viewpoints and viewing orientations. And there are roughly 2 different categories of volumetric media, which is video and audio. So for volumetric video, there are a couple of synonyms that you could consider with the term. One is immersive video, one is 6-stuff video, and even spatial video to some extent could mean the same thing. Volumetric audio then is kind of the audio part that is sometimes also referred to as immersive audio or 6-stuff audio. The diagram over here illustrates kind of how volumetric media in general is generated. So it starts with kind of a scene or object that you want to record. Then you capture that using whatever means at your disposal, and we'll talk about these capture means a bit further down the presentation. Then you process that captured content into a different representations. And because we're dealing with such massive amounts of data, it's almost always a good idea to somehow figure out how to compress or code that format into a friendlier, a bandwidth-friendlier data size. And then there's the delivery pipelines and finally rendering. And if you're still a bit lost on what volumetric video really is, I find that it's sometimes it's best to explain it as something that's somehow easy to understand, which is that when you when you watch the Star Wars for the first time or second time or how many, there was this volumetric representation of Princess Leia out there, and there it's kind of projected out, and people are able to then check it out from any viewing point, and that then kind of already tells of what type of a media we're dealing with. So then, hopefully that has clarified somewhat what the volumetric media then is. Then let's talk about a little of the use cases, and I have to just say that there are so many different application areas and use cases out there. I hope I can scratch the surface a little here, and bare minimum just to get you at least thinking of the possibilities that this volumetric video can offer to you and your businesses. First up, education. This is one of the areas which have been shown over and over again to have a very nice opportunity. The multiple studies have actually shown that when you engage in education in a volumetric media, it leaves longer memory prints, and as such makes the learning experience that much more efficient. And second one is digital twins. Today, it's easier than ever to generate 3D assets or 3D representations from the real world. So that brings a massive new wave of opportunities when it comes to sites and locations or factory equipment that you would like to generate a virtual copy of. Once you have kind of this virtual 3D representation of the whatever object you want, you can then marry it with other sensor data and kind of, create a digital twin out of it. Moving to communications, one of the interesting things with volumetric video is that it brings a very strong emotional connection when you're consuming the volumetric video. It's this kind of evolution when you think about Zoom calls where you see the other person's face as a 2D video and compare that with just hearing the other person's audio. With volumetric video, you can take it a step further, and it really feels like you're interacting with another person if you're wearing a headset or something else, that you can see the other person's impressions and nonverbal communication and everything. It just comes across very differently, and the emotional connection to those types of experiences is vastly different. Training, slightly related to education. So training in this regard is a little different in that it's kind of a more hand-to-hand type of a use case. So you can have this volumetric representation of another person, and then there's another person kind of brought into the same space, and then you can kind of jointly work on a project or a system or whatever to kind of train the other person to as if it were really there in your in the same space with you. Then additional use cases, and I mentioned sports here, not particularly necessary, not directly related maybe to enterprise, but it brings an interesting point. So what makes sports such an interesting use case for enterprise for volumetric video is that volumetric video allows you to place cameras where you physically couldn't place them otherwise. An example here shows that you can place this camera in the middle of the basketball field. Now, if you were to place a physical camera in the middle of the basketball field, you'll be dealing with, a bunch of issues. But with volumetric video, you can synthesize this kind of a virtual viewpoint from arbitrary point in the space. And when you think about the implications to enterprise applications, you can imagine that there's like a very rapidly moving piece of machinery somewhere, and you can't put a camera inside that region because otherwise it would be destroyed, or worse, the machine could be destroyed. So what you can do instead is you can place a rig of cameras around this area and then synthesize new viewpoints from within that space where you otherwise couldn't go into. Design and planning, as I said, generation of 3D assets these days is so much easier than it used to be 5 years ago, or even further back. And as such, it's a very useful tool for figuring out whether some design would fit in a place or not. So it allows you to have a kind of better spatial awareness of how an asset would look like in a particular point in your factory or some other region, and get an understanding whether you can still work around this asset or if you need more space to place it and so on. Then there's, of course, geospatial applications that have good, nice implications when it comes to automotive and navigation. So you can have more immersive navigation for your automotive applications, for example. And then I'm just going to quickly cover a couple of other use cases. So these might not be the ones that are directly relevant for enterprise applications, but some of your customers might be interested in these sort of scenarios. And some of these are applications or use cases that are generally thought as the most promising application areas in general for volumetric video, where the growth is expected to be. So for fashion and design, you can imagine that instead of looking at static pictures or maybe video of a model on your screen, you can actually bring the model wearing your clothing on your table or your living room or wherever. On entertainment, there are so many different varieties here, but it allows you to get always the best seat in the house, if that makes sense. So instead of your typical theater experience where you're sitting somewhere in the middle or back, you can be placed literally on the stage together with the performance. And this brings new opportunities for immersive storytelling. And well, imagination really is here the limit. Music is one of the important areas for volumetric video, along with spatial audio, obviously. Marrying volumetric video with volumetric audio support brings a whole new different level of immersion to your experiences. So those are very exciting areas. Then there's like application or use cases for preservations, for museums, basically, and then for art installations. Volumetric video obviously has its own kind of uniqueness to it. And yeah, then there's a really big list of other application areas, from travel to medical to gaming to virtual production, construction, or AI training. And with that, I hope I've covered sufficiently at least some of the areas of where volumetric video might be useful. And then we can dive in one level down on what and how volumetric video then can be captured in practice. So yeah, in the definition of volumetric media, I already mentioned that it is a captured content. So it always requires you to have cameras or other sensors that are capable of sensing what your volumetric scene is about. And generally, this can be divided into different categories, inside-out captures or outside-in captures. The difference here is that inside-out capture kind of allows you to model or record a scene of data around you where you can then walk around in. And then outside-in capture usually focuses on scanning or modeling individual objects where the camera rig surrounds the object or point of interest. Fully capturing a non-static object always requires you to have multiple cameras, because on one side of the object, if you don't have camera there to see the movement, then you will miss it. And as we're dealing with different capture systems and multiple cameras, synchronization of the capture is obviously critical. Otherwise, you will experience ghosting artifacts when you're trying to consume the content later on, and those are caused by some camera either being a little ahead of captured time or behind it. Then setting up the capture system fundamentally is finding the right balance between covering your source content sufficiently and not drowning in data processing or hardware costs. There are always bound to be some occlusions, and it is use case dependent on what is acceptable or not. For example, when you're using a outside-in type of capture and you have a person in the scene, do you always need to be able to capture the all the data for the armpits, for example? You probably don't. So just finding the right balance on what your use case is usually what you need to do or want to do when you're setting up your own volumetric video capture systems. On occlusions, there are multiple different interesting papers recently that allow you to fill in even the unseen areas of the volumetric content. So if you don't happen to have a camera shooting the armpit or backside of a person, you can let AI to fill in those details for you for your final representation. And that's an interesting, well, it can help you a lot, but then you'll obviously need to deal with the implications of utilizing this AI, and it might not be that straightforward for all of the use cases. For example, the ones that would rely very real data, something that you can't in no scenario hallucinate, or Then let's actually start to talk about these different types of capture systems that are out there, and start by addressing the first conflict on this page, which is that I said that you need always one camera or always multiple cameras. You can actually generate volumetric video with just one camera, but the type of experience that you will get is obviously going to be very limited. You can use a camera like the one here described, like the Orbe camera here, that captures depth and texture content. So that will kind of create a depth map along with your texture stream. And with that, you can record a single stream or surface of data. And for many applications, this is good enough. You don't necessarily need to see the background of back of someone's head if you're just interested in the foreground. And then there's the other side of things, that if you're just interested in static capture, what is very common these days is that you just use a single camera and you generate the content using that. There's also, moving on from the single or stereo camera capture, there are these lower end capture systems, which consist of a couple of or a handful of cameras, let's say 5 to 10 cameras. And with that sort of a capture system, you can already start to model like entire objects fairly accurately. And also what you can do is, if you're interested in inside-out type of capture scenarios, you can create these small rigs of cameras that allow you a certain limited viewing space volumetric video experiences. And together with these type of things, lighting comes typically into play, because, well, I mean, you'd ideally have to control the lighting conditions at least a little to make sure that all the texture information that the cameras get is properly aligned. Continuing on different capture systems, there's the next upgrade would be then a studio level system, which constitutes a higher number of cameras, let's say 10 to 50 cameras. And these cameras, they tend to be a bit higher quality from time to time. And obviously you will then get higher quality captures, and you can even capture multiple people using these kind of systems. Here you can see a capture studio from XD Productions that have, I think it's 48 cameras or something like that. And the capture space is already big enough to support these multiple people. With these studio grade systems, lighting and backgrounds, they're heavily controlled, and here they're even using green screen to make sure that the quality of their data and contours of their captured representations are nicely to get high quality of those captures. Then lastly, there are kind of a stadium grade systems, and here you can see Intel, you can partially see Intel TrueView system, which has around dozens of cameras and dozens of high-end cameras, which need to be able to zoom in quite close from far away distances. And then, you can then think about the types of experiences that these sort of massive volumetric video captures could get to you. There's a couple of things to note. One is that, as I mentioned, there's this Orbeck camera that is capable of recording depth information with its time of flight sensor. That might be very useful information for some applications, and it can help quite massively the speed that it takes from producing a volumetric video, like the representation formats. Having depth information goes a long way to speeding up those algorithms. So it might serve in some use cases to produce real-time experiences for volumetric video. That's something that you might need to consider if you're setting this type of a system. The drawback is that the time of flight sensors, they're not typically very high resolution, so you will end up with a maybe lower resolution representations, or you will somehow otherwise need to work around those limitations. Then 360-degree video, so spherical video, which is not technically volumetric video, but I just wanted to point out that sort of a representation can also sometimes have very good usability when it comes to your use cases. So you don't always need to go to volumetric video. Sometimes a 360-degree video will be better, sufficient or better. Then there's obviously the other types of hardware costs that comes along with capture setups. More cameras, more problems, more hardware you need to generate these representation formats that are used for then distributing the content. So the bottom line is that you will always need to think about the use case that you want to achieve with your volumetric video, and then figure out what is the ideal amount of cameras and other equipment that you need. Typically, it is not a good idea to overshoot quite a lot. Otherwise, you will then end up spending a lot of time post-processing your captured content, and that might come and bite you further down the road. Then moving to volumetric video representation. So what happens then after you have recorded your volumetric content? Usually you want to generate it into some sort of a more efficient representation, because the original data tends to have a lot of overlapping data. It's also important for easier distribution. These representation formats that I'm going to be talking about are also something that help you to visualize the captured content. So they're easier to reconstruct and render. And then there might be some compression tools and standards out there that ingest these representation format more or less natively. How these representation formats are derived depends then on the representation format in question and what the input format is. So if you have depth and texture, for example, or if you're dealing with some other types of data. One thing to note also is that when you're creating these representation formats, from the raw source content, you'll need to figure out your camera alignments and calibrations. There are a number of tools to do this. Colmap is very commonly used these days. And that basically means that you will need to calculate the relative positions of each of the input camera with relation to each other, so that you can then reliably generate these 3D representations of the captured content. And that is not always the most trivial process, but that said, there are some tools already out there that can help you a lot here. Okay, so then talking about the actual representation, starting with the 360-degree video, which is, again, not really a volumetric video because it has a fixed viewpoint. That said, some of the cameras out there actually have sensors that are overlapping a little, so you can accommodate a very limited viewing volume, view synthesis within the casings of those cameras. So it is interesting to think about that one as well. And again, these sort of video experiences are very good for some applications. What I typically do when, what I've shown to kids with volumetric video and with 360-degree video, they really love these 360-degree videos. If you have sufficiently interesting content, for example, like bouncing bunnies, the kids will just go nuts when they see this. With volumetric video, they have a little maybe harder time to understand what they're seeing. So 360 video, always a good idea to think if this could be actually what you need instead of volumetric video. Voxel or point cloud sequences. These are basically points with color and 3D coordinates in space. Sometimes dense, sometimes sparse. It's a very common intermediary representation format for graphics. It's relatively easy to generate. So it's just once you have the camera calibration and the understanding of the scene, you can just reproject these views into 3D space, and then you'll get your point cloud. Rendering is very straightforward as a collection of points. Sometimes you might want to clean it a little, because to represent a full object with just points, it tends to require a lot of points. Multi-view plus depth, and I have plus depth in brackets because you don't necessarily always need depth, or you can have implied depth like the multiplane images. This is closest to what kind of a visual representation of a volumetric video might look like. It's kind of a patched video from multiple cameras where they just remove the overlapping areas and then generate patches out of those and store them in the same canvases. The rendering works a little differently. So you have usually you'll need to look into some image-based rendering techniques or depth image-based rendering techniques if you have depth available. Moving to mesh sequences. Meshes, as you know, is one of the most common 3D formats or representations out there. Mesh sequence is basically then just a collection of individual mesh frames where the topology between the mesh frames doesn't need to be connected or constrained in the same way, built in the same way. Unless you're dealing with tracked meshes, which then kind of keeps this topology over a sequence of frames or a couple of frames at least. The meshes, importantly, are not rigged or skinned. So it is, in fact, a separate mesh per different frame, and the animation goes by just playing then these mesh frames in a sequence to generate the illusion of movement. You can generate this from point clouds, for example. And rendering is really fast with these typical rasterizers, which are very easy to implement. Then one newer format that I feel we should briefly talk about is these 3D Gaussian splats, or other primitives for that matter. And this is the latest very, very active and very popular research topic. Came out around 2023. And since then, there's been at least one paper per day published on improving different aspects. It is somewhat like a point cloud, but with additional primitive attributes. So in addition to just color and 3D coordinates, they will have covariance or transparency and view-dependent color attributes. And what you can do with these is you can achieve incredibly high level of detail or high quality. But the drawback is that these tend to require a lot of data to represent scenes using this manner. How you create these 3D Gaussians then is you generate or learn from them from image and video sequences via differentiable rendering, where you kind of backpropagate to find good 3D Gaussian distribution and its attributes for the scene or object. The benefit of this approach is that 3D Gaussians is that it's very fast to render using rasterization with just your regular alpha blending. And yeah, for 3D Gaussians, there are so many different flavors, even just this one single representation format. And there are other formats out there. There are neural radiance fields, there are light fields, there are motion capture animated avatars, which comes very close to these rigged or skinned meshes. And there might be something else as well out there. But I feel that the ones that I covered are probably the most relevant for your applications or use cases. At least they're the most interesting from the standardization point of view. Then considerations for streaming and compression, and this is maybe a lot of information for one slide. I'll try to run you through it very quickly. Volumetric video in general, it requires a lot more data than your typical 2D video, but it also heavily depends on the type of representation format that you're dealing with. If you're just interested in a single depth and texture surface, as a volumetric video experience, it's probably roughly 2 times as much data as your regular video would be. But then if you're looking into these 3D Gaussians and a scene that consists of 7 million Gaussians, per frame size would be then around 1.7 gigabytes. So there obviously needs to be some compression tools for that. The good thing is that you don't nearly always require these many Gaussians. I think an ideal ballpark for interactive experiences would be even around 50,000 to 150,000 Gaussians. I think with that number, you can get fairly nice representations already. Yeah, but still, the data size is massive, and there needs to be some further work on there that improves on the compression aspects. That said, there are already some standards and technologies out there focusing on compression of volumetric video. And I'm just giving some ballpark estimates here, and please don't quote me on any of these. With a point cloud or a projection-based point cloud coding, what you can expect is typically 3 to 20 megabits per second per your source content. And again, this heavily depends on the content, and this depends on your density and what you really want to achieve, what type of a capture system you had. Then geometry-based point cloud coding is a slightly different approach, which generally forms slightly worse for very dense point clouds, around 20 to 40 megabits per second. But something that you can still consider if the geometry coding of your point cloud is like it is the root cause of if that is what you really need from your application. And then there's multi-view based coding, 5 to 30 megabits per second, dynamic mesh compression, 5 to 35 megabits per second, and then 3D Gaussians is still subject to very active research. What we've seen is like some rudimentary experiences where they drop all the view dependent attributes from the 3D Gaussians. They get down to maybe 15 megabits per second. But then if you really want high quality, you might end up with something like hundreds of megabits per second. Some of the requirements from the industry is that it would be really nice if these representations and volumetric video could work on existing hardware. And you wouldn't have to have like a specialized system on chip implementation. So whatever video codecs are out there, whatever GPUs are out there, leverage those. Don't invent something new for this. And then for streaming, you could consider using Dash or RTB based protocols for transmitting your scenes and videos across the net. Then finally, coming to this display side of things. So how do you take the volumetric video and how do you visualize it? The key ingredient here is that the interactivity is the key. Without interactivity, you probably wouldn't benefit from volumetric video at all. It would be same as just transmitting your standard 2D video. And that said, there are multiple different ways of consuming the content. You can have a a traditional 2D display where you can navigate the scene or viewport using your mouse and keyboard peripherals or some other means, joystick, for example. You could have an autostereoscopic display, which has an eye tracking mechanism. And Asus introduced its spatial vision, I think, that actually does this quite neatly in a single laptop form factor. If you haven't tried it, it might be very interesting to try for you. You can do phones with an AR mode, XR headsets, and there are also some other form factors I've listed, Looking Glass and Voxel here, which have their own takes on visualizing volumetric content with a glasses-free approach. What I find is that, especially for communication use cases, XR headsets are excellent. The major drawback is that you're actually wearing something that sometimes blocks your face a little. The smaller the XR headsets become, the better. But the kind of sense of presence that you get with those type of mechanisms for interactivity is just incredible and very, very eye-opening to play around with those things. Finally, just a couple of notes on the rendering complexity. Point one is that it is heavily dependent on the representation format. Some representation formats are more efficient to render than others. It also heavily depends on the size of your scene or object, or the viewing space if you're using the inside-out type of capture. And sometimes you're working on battery-powered devices, so you'll need to be very mindful on how you spend your resources. So that might have an implication on what type of representation formats that might be suitable for you. And then there's interesting work that is going on related to split rendering or split processing, where you offload the rendering on an edge or like a GPU cluster somewhere in the network. And then you kind of just signal your view position and orientation to the network, where the renderer just then produces the frames and encodes them and delivers them to you as a regular 2D video. And then you can have like a asynchronous time warping on your side to kind of correct the minor changes of viewpoints once you're receiving this content. But that has kind of interesting implications or applications when it comes to these battery-powered devices. So that would mean that we consume way less power and resources on these devices, and also it could bring up new types of XR headsets that are only focused on these types of areas, and those might be then a lot more slimmer than some of the headsets that we've seen up today. Then I'll just very quickly run you through this volumetric media state of the industry survey that we did. I see that we're running slightly out of time, so I'll be quick with this one. So for background for the survey, we did a survey in this volumetric media interoperability group. We got 24 responses. These responses are from individuals who work mostly on volumetric media, and they are as such sort of like an expert opinion of this field. So we are treating the responses as such. what we wanted to do with this research was to find out who are working on these topics, what sort of momentum the industry has, and what the industry should focus on to kind of take the volumetric video to the next level. On the use cases, this is one of the areas that we asked in the survey. So we had 3 categories. One was what application areas would be most suitable for volumetric media. Second one was what volumetric experiences would increase market adoption. And third one, what application areas is your organization working on? And then we kind of derived some conclusions from this one. So you can kind of see a little bit of delta on what are the use cases that look most promising to volumetric media, but are not actively being pursued. So there's a little bit of like a space or nudge to consider if maybe there is space there to work on volumetric media. All in all, there are no large surprises here. The most potential areas or application areas are around sports, entertainment, and music. But there are a lot of activities on work-related use cases, which are not necessarily driving market adoption, but also there's not too many companies out there focusing on those. So it might be very useful very useful area to look into these ones in more detail. Art, education, and advertising are some of the less populated areas, which are considered then again more suitable for volumetric media use cases. And I don't know, maybe there are some organizations out there that might be interested in taking these volumetric video and these sort of use cases and seeing what they can achieve there. On future outlook, clear majority of the respondents consider the volumetric media entering mainstream 2027 or after. So this is not a technology that is already out there in mass. It's hopefully getting there. On average, the industry estimate that the market size is around 2 billion in 2023. And just for reference, the Netflix annual revenues are around 33 billion. So it's not a massive industry by any margin, but 2 billion, that's a lot of money already. And there's a lot of companies operating in this space competing for that 2 billion. Another interesting fact or outcome of the survey was that they estimate the compound annual growth rate for the following 5 years to be around 28%. And just for reference, Netflix CAGR is around 16% for the past 5 years. So we predict this market to be growing faster than sort of the industry average. We also asked the question of where you would be placing volumetric media on a hype cycle, and we got vastly different responses on this one. It was difficult to draw any conclusions. It's just that there are so many different varieties of volumetric media that some of them are further in the hype cycle and some are maybe just in the beginning. So maybe that explains this results a little. Now, how to speed up the adoption? We got quite clear message here. One thing that we need to do is improve the overall quality and availability of content. We should also look into the affordability of experiences in whatever way we can. And to put another aspect, also some other aspects here is that we need better technologies for producing the content. Some of the technologies for producing volumetric video are, well, they could be better, it seems. We need better end user form factors. Your typical phone screens are not usually the way to go with like slimmer headsets and other hands-free or other form factors where you don't need to wear anything on your head. And then furthermore, we need more pull from the customers. There are a couple of actions that we as an industry should take as a result. So we need to do a better job at educating consumers and customers. We need to be producing more commercially relevant open standards. reducing the complexity of these systems, especially for devices that are battery powered. And I see Christine jumping in. I'm almost there. Takeaways. Yes, key takeaways. There are many. So what you need to understand, there are many different flavors of volumetric video. You'll need to be smart selecting what representation format works for you and your use case and your capture setup. It is a very active area of research. As I said, there are papers every day being published in this domain, and it is really a very excellent time for you to start looking into this and figuring out exactly what you want to do. Fundamental considerations there, you always need a multi-camera system, except when you do static capture. You always require some interactive means of displaying this content, so it doesn't come alive into the display screens. There are many end-to-end services out there. Maybe we need some better interoperability in this place. Yeah, that's it. Most promising use cases for enterprise, AI, education, training, communication, digital twins, monitoring, planning. Here we are. Thank you.
Great. Thank you. Thank you, Lauri. This is so comprehensive. There's so much to say about this subject. It's difficult to compress it. It's like the subject itself. It's kind of iterative. So thank you again for your preparation. And I'd like to ask Mark if you could paste in the link if people are interested in the link to the recording of the town hall that was in the late 2024. It's very current. Lots of interesting content there that people could go to and explore more. So there's some questions, and I think we can probably address quite a few of these. You have mentioned, you've really iterated several times that this is a file format and a medium for interaction, that it's really not about passively watching this. It's really about entering and navigating and manipulating these files. You said that XR headsets offer, excellent experiences for viewing, but I'm wondering about the navigation, the interaction when you're in one of these volumetric videos. Is it a matter of pointing, or do you use the handheld wand, or can you share what is that like to interact with the volumetric video while wearing a VR headset?
Absolutely. So it's as natural as it comes. So when you're wearing your headset, you can walk around in the volumetric video and experience it as if you are like experiencing your everyday life. It's just that this time, like, it's data that comes from some other place to you. It is really as simple as that.
Perfect answer. That's what I was hoping you were going to say too. Another question, you speak about, one of the use cases being AI, but what I didn't hear you say a lot about is how is AI going to change the way the files are processed, maybe the way they're captured? What is it today that's at the intersection of volumetric video and AI, and where is that going?
Okay. Oh, that's a loaded question. There's so much to answer. First,
it's not the focus of this presentation, but I think it's on everybody's mind.
It's obviously relevant, and AI is getting everywhere. AI is getting into volumetric video in a number of ways. One is that it actually helps us in the generation process of deriving these representation formats. The second one is that volumetric video actually, like some of the raw captured video content, can be very useful for training AIs. So AIs can then kind of be the access point for volumetric video, if that makes sense. But it's kind of a two-sided thing. One helps the other, and the other helps the other side.
Bidirectional.
Yes.
But you don't know of any specific models that are being used about that today?
know what. I just know that it's out there. People are looking into it for sure.
Tell me about, you mentioned many times about standardization, but you haven't said any specifics.
Yes.
Is it too early? Is it too early? Is it too late?
For some representation formats, there are fairly mature standards out there. Why I don't talk about standards directly is that I try to be somewhat impartial and neutral. I know only subset of the standards out there, and I don't want to offend anyone omitting or misrepresenting their work. So yeah, there are tools. For some representations, it's very mature state. For others, it's really just getting there.
Very good. Okay, so one more thing. Are there metrology? Are there systems already for measuring volumetric video data, or for measuring distances in a video, in the file? You know, so where are we going with measuring these experiences? Sports would be very, very important, right? You want to measure the speed of the athlete or the height that it's jumping.
Yeah, so you mean kind of physical measurements of the medium? It's interesting. I really haven't thought about it. I suppose you need to somehow have a very concrete idea of the geometry of the scene that you're dealing with, and then you can maybe just treat it as any other measurement of sorts or
Okay,
medium.
let's finish up with just one more question in our group. So you've mentioned great use cases. Who is doing this in enterprise and industrial settings? Can you name any companies? And how would a company get started? You know, okay, is there a tutorial? Is there a GitHub repository? How do you get started?
Yeah, so that is something that our working group will look into for sure. So we will try to bring out this information better out there. There are some reference tools for some standards that are hidden in the bureaucratic wheels of standards developing organizations. Those need to be better available to the general public. Also, as you witnessed today, it's a bit of a jungle out there. So if you don't know exactly what you're looking into, you might get confused on like, okay, do I need point clouds or do I need multi-view video? Like, where do I get started? Like, someone needs to do the job of training and educating the general public on like how these technologies can be brought into use already today. There must be companies out there that are using this. I don't know, like there are small startups for sure that I can list dozens of that are offering these services to their customers on a number of use cases.
It's so exciting. It's so cutting edge that people don't want necessarily to disclose the details of their experiments and the results they're getting today, because that's their competitive advantage, right? Mm-hmm. It's a valuable information. So, well, this is such a great education, so much good content. Thank you very, very much for preparing and delivering this webinar, and I look forward to the next chapter. Thank you, Lauri.
Me too. Thank you.
Bye now.